So on this video, we are going to describe how to graph logarithmic functions. Okay, now this is going to be a little complicated, but I will show you an easier way after the first method. So just try to understand it. The key is to make an XY table. Just like any other function, plug in convenient numbers that work for you. All right. So let's take a look at this logarithmic function, y equals log base 3 of x. And do me a favor, on the side of your notes, how about you write down that function, it's right here, log base 3 of x, and then make a quick XY table right below it. And I already did certain inputs, but let's go one of them at a time. If I were to plug in a -1 into here, would it work? In other words, 3 to a certain power, does it give me -1 as an output? The answer is no, right? 3 to the 0 is 1. 3 to the 1 is 3. Even if you plug in a negative right here, it's not going to give you a negative 1. Did that make sense? No? Let me repeat that. I cannot plug in -1. It just doesn't work. Because when you think about the concept of logarithms, you're thinking the base. 3 to what power gives me -1? There is no, it doesn't work. 3 to the it just doesn't work. You can't get a negative output. Does that make sense? Now this is a little confusing because we're talking about inputs here. Now how about 0? Could I plug in 0 into here? Would it work? In other words, 3 to a certain power give me 0. 3 to a certain power give me 0. Anybody? It doesn't work either. Right? Because 3 to the 0 is 1. It doesn't give me 0. 3 to the 1 is 3. And even 3 to a negative number will not give me 0. All right? Like 3 to the -1 will give me 1/3, not 0. So my point is this. 1 didn't work. 0 didn't work. I mean, -1 didn't work. 0 didn't work. Let's try 1. Does 1 work? Yes. If I plug in a 1 right here, 3 to the 0 gives me 1. Yes? This is all kind of confusing. Like I said, it'll make a little more sense right now. If I do plug in 1, I get 0 as my y value. So ladies and gentlemen, we have a coordinate right here, 1, 0. If I plugged in a 2 right here, 3 to a certain power give me 2? Not off the top of my head. It doesn't work. So I'm not going to use 2. Let me try 3. Will 3 work? 3 to a certain power give me 3. Yes. And what would that power be? It'd be 1. Okay. And then how about 9? 3 to a certain power give me 9. Yeah, 3 to the second gives me 9. So I have these coordinates that I found, and obviously it's a little bit challenging. You just don't plug in any numbers you want. You can't even plug in 0 in this case. Why can't you plug in 0 again? Because 3 to a certain power will not give you 0. It just doesn't happen. And we already tried plugging in a -1. 3 to a certain power give me -1. No, it doesn't happen either. So 0 didn't work, -1 didn't work, 1 does work. What happens as we get closer to 0? Well, if we think about that right here on the side, what happens as we get closer to 0? In other words, if I were to plug in a 1/3 in here, 3 to what power gives me a 1/3? -1. So that's another coordinate that does work. How about 1/9? 3 to what power gives me 1/9? -2. Okay? And 3 to what power gives me 1/27? -3. Okay? So something's happening here. As I get closer to 0, because 1/3 is close to 0, but 1/9 is closer, and 1/27 is even closer. As I get closer to 0, my outputs get more negative, as you could see. Now, I'll be honest with you. Thinking of logarithmic functions and making an XY table for them, for me, it's kind of confusing. How about you guys? Or you guys got it? You guys got it down? You guys could do that? Because if I graph these coordinates, I'll be able to see my graph. But the thing is, I want to make it easier for you guys. I want to make it easier for myself. So this is what I want to do. One more time, I'm going to rewrite the function. And do me a favor, write it again down there, log base 3 of x. And we're going to apply a little trick. And my trick is this. I think it's a lot easier to graph an exponential growth function. So I'm going to do this. Look, I'm going to take this little block that I have right here. And, well, first of all, let me, hold on a second. There you go. I'm going to put that little block right there, and I'm going to cover up the log. Okay? So you could use your finger, whatever. Or you could just ignore the log for a little while. And what does that function look like? It doesn't look like y equals log base 3 of x anymore. It looks like y equals 3 to the x. So the trick is to just cover up the log and pretend that it's an exponential growth function. Now, why would I do that? Because doing an exponential growth function is really easy to get the x, y values. Just use consecutive integer inputs. Remember, -3, -2, -1, 0, 1, 2, 3. And you probably are not even going to use all these. But if I do plug in 0 into my into the exponent, I'll get 3 to the 0, which is 1. And of course, I could continue plugging in, or I could use the base as the pattern. You guys remember exponential growth? Yes? No? Okay, so we're going to use the base, which is multiplying by 3. So when I go 1 times 3, I get 3, times 3, I get 9, times 3, I get 27. And backwards, if this is multiplying by 3, going backwards is dividing by 3, or multiplying by a third. So 9 times a third is 3, 3 times a third is 1, 1 times a third is 1/3. 1/9 is the next one, and 1/27 is the next one. So we have all of these coordinates, but these coordinates are to the equation y equals 3 to the x, not to the logarithmic function. So what do we know about exponential functions compared to logarithmic functions? They are inverses of each other. Yay? Yay. Now, what's the definition of an inverse? How do you find the inverse? You switch x and y, correct? So if I want my actual x, y values for my logarithmic function, all I have to do is take these blue coordinates and do a switch. Switch the x and the y's. So in other words, instead of the coordinate -3 and 1/27, I want to have my coordinate 1/27 and -3. Instead of -2 and 1/9, I want to have 1/9 and -2. Instead of -1 and 1/3, I want to have 1/3 and -1. Instead of 0, 1, I want to have 1, 0. Instead of 1, 3, I'll have 3, 1. Instead of 2, 9, I'll have 9, 2. And of course, instead of 3, 27, I'll have 27, 3. But that's already off the graph, so I'm not even going to use it. So because I know that the inverse of log base 3 of x is y equals 3 to the x, I might as well get these simple coordinates, and instead of using them, I'm just going to switch them. And that'll actually give me the real coordinates to this new logarithmic function. So now I could focus in on graphing. And let's start with the easy ones like 1, 0. If I graph 1, 0, 1 on the x, 0 on the y, it's right here. If I graph 3, 1, 1, 2, 3, 1 is up here. And if I graph 9 and 2, it's all the way over here. Now what happens when I get closer to 0? Now I know I can't use a 0 or negative numbers, but what happens as I get closer to 0? If I go to 1/3, 1/3, that's not even halfway, but the coordinate 1/3, -1 for y. So if I go 1/3, not even halfway, -1, I end up right there. Well, that kind of looks like halfway. My bad. Should be a little bit less than halfway. And then if I go to the next one, 1/9 and -2, let me zoom in here. If I go 1/9, which is hardly anything, right? 1/9 is practically 0, and -2, it's going to be right there. And if I go to the next one, which is 1/27 and -3, that's 1/27. It practically looks like it's on the 0 on the x. So I really do have an infinitely approaching, what we call asymptote, and in this case, it's the y-axis, the x equals 0 line. And all I have to do is connect my dots here, and I have my graph of my logarithm. So I believe that graphing the inverse is a lot easier to get the coordinates and then switching coordinates and then graphing them. What do you guys think? Not bad, huh? Now, if I were to have graphed my blue function, which is an exponential growth, we all know that exponential growth start off at nothing, so it looks like, oh, that's disgusting. But exponential growth is going to look like this, right? And once again, we know that it's truly a reflection over the y equals x line. Okay? Now, we don't have to do all of that, but I just wanted to show that, mention that to you guys. Anyhow, let's move on.
I have a question.
Yes, what's the question?
Why did you tell me that I should go?
Let me pause that right here. Guys, we have about 3 minutes left, so let's try to cram this one. If you understand this one, you'll understand any of them. Now, you want to graph this guy. This does have a h and k shift. The h of the logarithmic function is -3. The k of the logarithmic function is +1. So that means 3 to the left and 1 up at the end of it all. What am I going to do, though? I already identified h and k. For a little while, I'm going to ignore h and k, and I'm going to focus in on log base 2 of x. Now, how do I get coordinates for the parent graph log base 2 of x? I do this. I cover up the log and make it look like an exponential growth function that says y equals 2 to the x. So that's what I want to write down over here on the side. I want to write down y equals 2 to the x. Now I'm going to make an xy table for it. Now I'm going to plug in consecutive integer inputs, -3, -2, -1, 0, 1, 2, and 3. And I'm going to work this out. So 2 to the 0 power is 1. So when I plug in 0, I get out of 1. And I could use the base to give me the pattern, which is just multiplying by 2. So 1 times 2 is 2, 2 times 2 is 4, and then 8. Going backwards would be multiplying by the reciprocal of 2, which is 1/2. So 1/2 would be right here. And then 1/4, and then 1/8. Now, of course, we know it keeps getting smaller and smaller, infinitely approaching 0. Now, those are the coordinates to the function y equals 2 to the x. That's an exponential growth function. We don't want the coordinates to the exponential growth function. We want the coordinates to the logarithmic function. So all we have to do is switch. Switch x's and y's, and that truly gives us our inverse. So instead of -3 and 1/8, we're going to have 1/8 and -3. Instead of -2 and 1/4, we're going to have 1/4 and -2. And let me just do this quickly. There we go. So I've switched all the coordinates, and now at this point, I want to graph the coordinates, but these coordinates are technically the coordinates to the parent graph, so I'm still going to have to do a h and k shift later. So if I go for the easy coordinates like 1, 0, I have a dot right here. Okay, I apologize. We've run out of time. I will not be able to graph these. Just remember, you graph these coordinates, and then you have to make a h and k shift according to your h and k from your original, which is 3 to the left and 1 up. I could do that on the next video.